Hello and welcome to my part 3 of my gym build. In this video we'll be looking at how I've done the walls, and from this angle we'll get a better view of the internal framework and the external framework that I've done to create this 2-layer setup to minimize any sort of thermal bridging to allow greater depth of insulation as well. One of the things that I didn't make clear in my previous videos was the reason why I dug down as deep as I did. So under planning permission, you can only build a outbuilding 2.5 meters in height, measured from the external ground from the highest point, before you need planning permission. And this is for a flat roof design, which is what I've gone for here. Now, because most gyms you need quite a bit more internal height, a lot of the equipment, particularly I wanted a Smith machine in mind, which meant that the height of the room made quite a difference to things like the pull-up bar and things like that, as well as the fact that I wanted to put a climbing wall in the gym, and that requires a bit of extra internal height. Now, when we're talking about the internal height, we've got to keep in mind that the insulation on the floor and the insulation in the roof, the thickness of the roof, the thickness of the floor, all take up some of that internal height that you might have. So when we're looking at a regular outbuilding, one that you might be able to buy prefabricated or whatever, if you've got 2.5 meters of external height, by the time you've taken 100 mil or 120 mil off the floor, and maybe another 100 mil, 120, 150 mil off for the roof, you're actually only left with 2.1 meters, maybe 2.2 at most internally, and that's just not, for me anyway, that didn't feel particularly high. I think a lot of the equipment would have struggled to fit in there. I certainly wouldn't have been able to put a climbing wall in there and make it actually usable. And for things like pull-ups and things like that, overhead presses, that would have been quite limiting. So that's the reason why I dug down as deep as I did. The only downside with that is it makes the construction process a little bit trickier when you're working from the inside. Obviously, all the timbers are much higher than you, and when you're working from the outside, it's okay, but my garden slopes from left to right, so it's higher on the left side than it is on the right side, which wasn't too much of a problem, but when you're by yourself, it just makes that work a little bit slower, and you have to be a little bit more careful. So what you see here is me just putting up the last bits of the internal framework, and these bits of timber are 150 mil by 45 mil, and this is what will take the majority of the weight loading from the roof. It allows me to put in a good amount of insulation between the studs as well, but in a minute you'll see me starting to put up the external framework as well, which allowed me to put in the soundproofing insulation on the outside as well. Now, in this part here, I did fortunately have a little bit of help. These videos are taken over 2 days. The first day, I just felt it took far too long to do what I wanted to do. So the second day, I got a little bit of help from my wife and a few friends, just to make things go a little bit quicker. And of course, on this day, I was putting in the second wall strapping, wall plate, whatever you want to call it, on the top. Some people leave it as just the one bit of wood across the top, but I wanted it a little bit more rigid, a little bit more strength. My spans of my roof beams were 4.8 meters, so it's quite large, and because my roof beams are actually quite big in themselves, and I wanted 18 mil ply. It's quite heavy, the rubber's quite heavy, it's got to take load, and also I want in the future solar panels on the roof, so it needed to be quite sturdy. So it might look slightly over-engineered, that's fine. I wanted everything to be a little bit over-engineered, although I wasn't getting any sort of building regulation approval. It didn't need to, because it's less than 30 square meters internally. I just wanted to make sure that all the specifications that I had were above and beyond what the current regulations are for building control. So here we see the external framework going in, and it's offset from the internal framework to avoid the thermal bridging. These studs were 100mm by 45mm, and it provides somewhere to fix the external cladding to as well, and that meant it has used the full depth of the wall of 225mm that I'm able to fill with insulation. I use both PIR and soundproof insulation, Rockwool soundproof insulation as well, so it's a bit of a combination. So I'm just putting the bracing up on the framework. I was conscious that without a roof on and without the noggins in the studs, that there was a lot less support for the whole structure. So it's a really good idea just to brace it up a little bit. And yeah, so the second wall plate on the top is just going in just to add a little bit more strength and to tie it all together, tie all the corners together as well. The window frame section went in, not the window itself, but the opening for the window. And although you can't see it very well in this angle just here, you will in the next video. So I hope you enjoyed this video. This is the third part. Please stay tuned for the fourth part that I'll be uploading shortly. Do like and subscribe, and hopefully you'll get to soon start seeing me do the insides. Thanks very much for watching.